to upgrade my iMac. So
Okay.
there we are. We're all set, and I guess he's facing these Piecewise things this week. I talked to his teacher, and they just started him at the end of the week, and now they're getting into him with this assignment here. So this is what we want to do.
All right. The trick on piecewise functions is to focus on the right side of it, right there. Instead of starting with the left, start with the right. Okay? So this says if x is less than or equal to 1, that's everywhere that side of the graph.
Yeah, let him catch up just for a second, David. We got the papers mixed up, so.
Okay.
All right, so. Just tell Dave when you're ready.
Ready.
Okay. So everywhere to the left of 1 and even equal at 1, we're going to graph the function x minus 2. So how does that function graph? Where do I start?
-2.
Okay. What's the slope?
It's non-existent. It doesn't have a slope.
Here, I didn't draw this very good to scale. What in the heck? Oh. Hold on a moment. I've lost my cursor. Boy, that doesn't happen very often. Hold on, let me open it again. See if I get it back. Yeah. Okay, so everywhere to the left of 1, we're going to graph the function x minus 2, and we're going to start that right there at minus 2. What's the slope of x minus 2?
It doesn't have one.
Actually, it does. It's in y equal mx plus b format. So that's the slope. Well, what is that in this case? Since we have x minus 2, b is minus 2, m is 1. In other words, if the coefficient is 1, they don't write it. So you have to look for that. In other words, when you don't see a coefficient, you have to know that it's 1.
It's 1.
Okay? So that makes the slope 1. So here's my first point of this first graph. And my second point would be up 2 over how much? Or let's go up 1 over how much?
2.
Which way?
Yeah. Sorry, to the right.
Okay, if we went up 2, I would go over 2. But if I'm only going to go up 1, I'm only going to go over 1. In other words, our slope is 1. That means that ratio has to be 1. Okay, now let's pretend we plot this entire line. Well, essentially what this is saying is that this line is only going to be that if I'm to the left of 1. So I can erase that part of it and plot just that with a solid dot because it says less than or equal to 1. So in other words, starting with this, we graph that line wherever that is true. Okay. Now, the second part says, well, when x is greater than 1, which is everywhere in that direction, I'm going to graph a different line. I'm going to graph the line 2x plus 3. Well, where does that start?
That's 3.
Okay. So I go up to 3. And it starts right there, and it starts with an open circle because it's greater than 1, not greater than or equal to 1. And what's the slope on this line?
It is
Okay, so how do I draw my next point on that line?
you go up 2 over 1.
Correct? Over to the right one, yeah. In other words, I go up 2 over 1, puts it right about there. That's enough to draw the line. And that is the graph.
Now, David, do you have on the end of that line you just drew, is that x 1, y 3? Because Patrick has it graphed on x 0, y 3. You know, the end of the one you just drew with this open circle on it?
Yeah, the coordinates of that are 1, 3.
Yeah, see, yeah. And all right, and explain that. How did you get that wrong? You know?
I just drew.
Okay, because when he said that you were, was it when you were coming up and over? Is that what it was? Do you understand now?
The trick, Patrick, is to really start with this over here, not with this over here. We're used to reading stuff left to right, but with piecewise functions, you're better off going right to left. In other words, starting with that right there where my cursor is shaking, I'm going to start right there. Whenever x is less than or equal to positive 1, my function is this straight line right here. But whenever x is greater than 1, not greater than or equal, but greater than, then the function is different. It's got a different slope, it's steeper, it intercepts the y-axis at a different point. Except it doesn't go all the way to the y-axis. In other words, this thing doesn't extend all the way to here. It starts there and ends there. So that's the essence of piecewise functions, is to pay attention to the x-coordinate when you graph it, and just start from left to right. In other words, I'm going to start from somewhere over here, and I'm going to graph something up until x equal 1. And that function is going to look like that. Let's do another one. Okay, this one has 2 pieces to it, and they're separated at the point 0 on the x-axis. So the first function is going to be everywhere to the left of the y-axis. That's where x is negative. Now, notice that this starts on the right side. In other words, it starts where x is positive. That's okay. I don't mind that. We can go to the right first. So let's do that. We don't have to go left to right. It's usually best to go top to bottom. So really what this says is everywhere to the right of the y-axis. Okay, so everywhere to the right of the y-axis, I'm going to draw this function here. Where does that function start?
Starts at 3.
Okay. What is its slope?
-2.
So how do I get that kind of a slope?
You you go over 2, down 1, right? To the left.
It's the rise over run. So always do your up or down first.
All right, so you go down 2, over 1 to the left.
Which way? Over.
Left.
Well, if I did that, that's where my point would be. I would go down 2 and left 1. What kind of slope is that? Positive or negative?
Positive.
We want negative. It's -2. So I got to go down 2, right 1. There is my line. And it goes anywhere x is greater than or equal to 0. So that's the line. And it starts with a closed dot because it's greater than or equal to 0. In other words, if it's 0, if x is 0, then it's equal to this function right here. It's not equal to this function. Okay, now let's go to the left of the y-axis, wherever x is less than 0. Where's the y-intercept on this one? That's still in y equal mx plus b format. Only it's 2x. What's b?
0.
Uh-huh. So we're going to start at 0. And we're going to start with an open or a closed circle?
Is it open?
Yeah, because, excuse me, it's because that. It's only when it's x less than 0. So when x is equal to 0, it's actually this function up here. So only when it's x less than 0. What's the slope on this line?
It's 2.
Okay, so how do I draw that? How do I draw my second point here?
Go up 2 over 1 to the right.
Okay, I could do that. I could go up 2 and over 1, but notice that puts my point outside of its domain. My domain is only left of 0. So what's a better way to get my second point?
Yeah. So it's up 2 over 1 to the left.
Okay. Or actually, if I went up 2 over 1 to the left, that would be a negative slope. I don't want that either. That's a negative slope. How do I get my positive slope and stay in the range that I want to be in, which is to the left of the y-axis?
Would you go down 2 over 1?
Which way over? Yes, you go down 2. Which way over?
To the left.
Right. There's my second point right there. And it starts there, and it goes through the point forever. That's my graph. And that's the way you handle these piecewise functions, is you always focus on this part of the piecewise function, and then you draw it however this says. And notice this is a function. It passes the vertical line test. If I draw a line there, I only encounter one y. If I draw a line right here, I only encounter one y, and that's that one right there. And then if I draw it anywhere else, of course, I only encounter one y. And that's what makes a function. It passes the vertical line test. All right. This function has 3 domains on it. In other words, there's 3 areas on the x-axis that we have to pay attention to. Where's the first one?
Hold on.
Less than -1. In other words, everywhere there. So, what is y when x is less than -1?
It's 0.
No, what does it say?
-1.
Uh-huh. In other words, when it says f of x, that's the same as y. So it's saying that y is equal to -1 whenever x is less than -1. Well, how do I graph the function y equals -1? What kind of line is that?
It's a undefined line straight.
It's close. You're close. It's a 0 slope, which is horizontal. Vertical is undefined, but horizontal is plenty defined. It's defined right there. In other words, whenever x is less than 1, excuse me, I didn't draw that right. Hold on. Whenever x is less than 1, then y equals minus 1. And it's an open dot, open circle right there. Okay?
Okay.
And then the next interval, going left to right, is the interval between minus 1 and 1. Well, let me put 1 over here. That's this interval right here. Okay? And notice that it's less than, greater than or equal, and less than or equal. So it's closed dot everywhere, wherever this thing begins. Now, where to draw the closed dot? Well, if you substitute minus 1 in for x, what do you get?
You get a slope of -1.
Well, you get y equals x, or y equal minus 1. So the very first point comes right here, and it makes that open dot closed. What's our slope of this middle function?
Middle function? It's 1.
Okay, and I'm going to draw that line in that region right there. So starting from the closed dot, where's another point that I can find?
You could go up 1 over 1.
Okay, that put up 1 and over which way?
Sorry, I keep forgetting to the right.
That's all right. Everybody does it. I'm not sure why, but okay. So in this whole region, I'm going to have a slope of 1 up to that point right there with another closed dot, and that's 1 because when x is equal to positive 1, y is equal to 1. So the coordinates on that point are 1, 1. Now, the very last part is everything to the right of 1. Well, what is y equal to the right of 1? In other words, to the right of 1, what is y equal to?
1.
Which is what kind of line? Horizontal or vertical?
Horizontal.
Notice that y is equal to 1, no matter what x is, once you get to the right of 1. In other words, when x is 2, y is still equal to 1. When x is 5, y is still equal to 1. So that's how I end up with this graph. Now, I don't mean for this to be a closed dot, but this is, and because it connects, in other words, because this is continuous, I don't actually need that big, huge dot there or here. In other words, this is the function right here. And you can see that when x is equal to minus 1, y is minus 1. When x is equal to 1, y is 1. And this function looks exactly like this. Continuous everywhere. Now, continuity, just for your information, is defined as not having to pick up your pencil. That function is not continuous because in order to draw it, I have to pick up my cursor. On the other hand, the function we were just looking at, this one, that's continuous because I can draw that, even though it's piecemeal, I can draw it without having to pick up my pen. I can draw it like this. That makes it continuous. And continuity is a key property in math. You may not be discussing it yet in your algebra class, but you will before too long. All right. Where's my key dividing point here?
One of them is to the right of the y-axis and one of them is to the left?
No. Always start here. The y-axis is where x equals 0. So that's not our dividing point here. It's where x equals 2.
Oh, sorry.
It's okay. So in order to graph the first point, we want to go to the left of 2. But in order to figure out where we start, plug in 2 for x.
See that? You're plugging two there.
So where's my first point if I'm going to draw it? In other words, if I'm going to go in that direction, where do I want to start my point?
Hold on. Sorry. 2x, yeah. 4x.
Okay, so I'm going to start where y equals 4. In other words, right here.
You had x.
And I'm going to start with an open or a closed circle right there.
Would it be closed?
Well, at the moment it would be open. It might turn into closed depending on how the rest of the function goes. But that's our starting point, and remember I'm heading to the left. So what is my slope of that function right there?
It is undefined.
Oh, look at this function right here.
Oh, sorry. It's 2.
Okay, where do I get my second point then?
You could go up 2 over 1 to the right.
Remember that we're talking about this part of the graph. So let's not go to the right. Let's make sure we go to the left.
All right.
So how do I get a slope of 2? By going to the left.
You could go up 2 over 1 to the left.
Yeah, or in this case, down 2 over 1. Notice why I don't want to go up and over, because this is a positive slope. So if I went up, I'd have to go over to the right. Again, that's not in the area that I don't want to draw. I don't want to draw this line in this area, because it's only 2x when x is less than 2. So I definitely want to go down 2 over 1 to the left. That creates this line here. And that's part of my function. Now, at the moment, all I know is that that's an open circle. It may turn into a closed circle or a circle that disappears. So let's examine to the right. In other words, I always go from left to right when I'm doing these, unless that one we came across was top to bottom. But so when I'm going to the right, where do I start? At this point right here. When x is equal to 2, what is y equal to?
Would it be negative 2?
No, plug in 2 for x right there.
That would be negative 4.
Right. So I go down to negative 4, and I'm going to start my function right here, and I'm going to start it with a closed dot because it's greater than or equal to 2. Now, what's the slope of this line?
Negative 2.
Okay, so how am I going to draw that? Remember, I have to draw it in that direction.
So you could go down 2 over 1 to the right?
Yeah. There's a slope of negative 2. And that's the way this graph looks. And this graph is not continuous, because I couldn't draw it without picking up my pencil. Now, had this ended up starting up here and going down like that instead, well, I would have eliminated my open circle altogether, because it would have been continuous. And when it's continuous, you don't make an open or a closed circle. You only do that when it's not continuous. All right.
Because that's continuous.
All right, so here they're giving us the function, and we have to come up with everything that goes inside there. Okay, so let's start from here. Let's go left to right. On the x-axis, in other words, here's what I'm looking for. This part of it for beginners. In other words, what is the domain over here? How would you specify that? X is greater than what and less than what?
You look where the graph starts. The line.
The x-axis is what we're looking to, not the y-axis. What is the x-coordinate of that point right there?
Coming up.
If you count it out, it's 3, 6, negative 8. Okay? So I'm going to say when x is greater than or equal to minus 8, and the reason I say that is because that looks like a closed dot to me, up to this point here. Well, what is x right here?
It is negative 2.
And that's also a closed dot. So that's the way I would write the right side of this thing. Let me move it over even a little bit so I have room. So I'm saying whenever x is greater than or equal to minus 8 and less than or equal to minus 2, that's that region. Well, what is the function? In this region only. What's the slope?
Oh, it's up.
That's what your information's about here.
Most important thing about the equation of a line is the slope. So that's always the first thing you want to look at. So what's the slope of this line? How many down do you have to go and over? Divide those two numbers.
Alright, so it's down 2 over 2.
Is that a positive or negative slope?
It's negative.
What is it? Negative what?
Negative 2.
Negative 1. We go down 2 over 2. Or down 1 over 1. In other words, it's not how many you go down, it's the ratio. It's 2 over 2. Or 4 over 4. Those are all slopes of 1.
18 hours.
So I would write it like this, only we don't need that negative 1. So I'll just leave the negative x. Now, that's not the full equation of that line because it would have a y-intercept. Where would that intercept the y-axis if it kept going?
Looks like it'd be about negative 2.
I think it would be right there, negative 3. In other words, starting from there, if I go down 2 and over 2, which is a slope of 1, negative 1, then it ends up right there. So the equation of that line is going to be minus x minus 3. There, let me rewrite this a little bit better. So, in that interval, the equation of the line is that. Even though it doesn't go all the way to the y-axis, it doesn't matter. If it were to go, in other words, the equation of that line is the same regardless of whether it goes all the way to the y-axis or goes all the way to positive infinity. It is where it would intersect the y-axis if it kept going. And that's how we come up with that line. And notice that we don't really have to do it that way. If I put in x right there as minus 2, well, if I put in an x of minus 2, I get a y of minus 1. Well, that's exactly what I do if I put in an x of minus 2 right there. You get minus of minus 2 minus 3, which is minus 1. So really, you can come up with this equation even if you don't. There's a couple of ways to do it. I did it by pretending it extended all the way to the y-axis, figuring out where that y-intercept would be, and putting the thing in y equal mx plus b format. Okay? Now, what's the next interval we're dealing with?
Hold on.
In other words, this interval here.
It's hard to see, so.
Yeah.
Hold on a second, it's sort of hard to see from
Yeah,
here.
that is a open circle and that's a closed circle. And they haven't put a grid on here, so we can only assume that every square is 1. Okay, so where does it begin? On the x-axis, right there.
-2.
-2. Greater than only. And less than or equal, where's this on the x-axis?
About 4.
Yeah, 4. Okay. Now, what I need to put here is the equation of that line. Well, that's not very hard. We can read the slope off of it, and we even see where the y-intercept is. Although the problem here is the y-intercept does not appear to go through a nice number. So let's start with this point here. Well, let's start with the slope. What's the slope of that?
It could be a +1.
Well, let's see. Starting from an integer, both x and y, there, and going to an integer of x and y, notice that if we read any of these points in between, it's questionable whether we're actually on the vertex of one of those little squares. But clearly here, y is equal to 3. And clearly here, y is equal to 3, 4, 5, 6, 7. So y goes from 3 to 7 when x goes from -2 to 4. What is that slope?
Hold on real quick. Would be -4 over -2, or would it be +2?
Well, let's do it by y sub 2 minus y sub 1. Slope is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. That's rise over run. Now we can see looking at it that that's positive, right?
Mm-hmm.
So our answer has to come out positive. So, what's y sub 2?
That's -4.
No, it's this one right here. That's the second y coordinate. So that would be 7 minus 3 divided by what is x sub 2?
4 minus 2.
4 minus a minus 2. In other words, what we're really looking for is the distance between the x. Well, what is that distance? It's not 2. It's not 4. It's 6. In other words, you got to go 2 to get to the y-axis and then 4 more to get over to there. So when you do 4 minus a minus 2, you get 6. Or 4 divided by 6, or 2/3. So we know the slope of that line is 2/3. So it's 2/3 x. Now the only question is, what is b? Well, this gets a little tricky at this point. In other words, we can't really read B from the graph because it's in between lines. We could approximate it, but that's no fun. Let's come up with a B. It's clearly positive. That works. I know the slope is exactly 2/3. And I know that y equals 2/3 x plus b has to be true at any point that I know the point's at. Well, I know it's true when x is equal to -2, y is positive 3. So that will let me solve for b. In other words, I could read b, except I can't really read it very accurately from the graph. So let's come up with an exact value for b. Well, I know that when x is -2, y is +3. So I can immediately plug in for that x and y value. And then I'm going to solve algebraically for b. Well, now I get 3 equals -4/3 plus b. What's the next step of solving this equation?
Division.
No, I'm adding right now. In other words, let's go back and look at how we decide that. This is what I've got. Okay? I'm trying to isolate b. Well, what does b have going on right now? It has a -4/3 being added to it, which means to get rid of that -4/3, I have to subtract that. Not divide or multiply. You always do the inverse of what it is doing. And since I'm trying to get rid of it, I need to add 4/3. Because right now, really, I said it's being added, but really it's being subtracted because of the negative sign. So 4/3 is being subtracted from b. To get rid of it, I got to add 4/3 to both sides of the equation. Well, the left side becomes 4 1/3, and that's equal to b. So that's what that point actually is 4 1/3 on the y-axis. So now my equation, since I know b and it has to go in there, is 2/3 x plus 4 1/3. And that's how you do it. When you can't read it from the graph, you can algebraically come up with it by reading the points that you can read. In other words, I know exactly what that point is right there. That point is x equal -2, y equal 3. I also know what that point is right there. That's x equal 4, y equals 7. So because I have integer values for that and that, I can figure out the slope of that line quite easily.
With your regular formula.
Figuring out the y-intercept, which is the number that goes right there, is not so easy to do from the graph. I can come close. I can tell that it's slightly above 4, but I don't know if that's 4 1/3 or 4 1/4 or 4 1/8. So if I really want to come up with that exact value, then I plug it into that much of the equation that I know, and then I know a few points on that line. I can plug in if I plugged in 7 for y and 4 for x, that would also work. That would also allow me to solve for b, and it would have still come out to be 4 1/3. All right. Okay, again, they're giving us the graph, and we have to come up with the equation of it. So, I got f of x is equal, and let's start with that part. where is my first interval?
-3.
X is less than -3, X is greater than -3, what?
The open circle means it's greater than, right?
Well, no, that means it's not equal also. The open circle means it's either less than or greater than, but which way are we going? We're going that way. What is that?
Negative slope.
No, well, it is. We'll get to that in a moment. But at the moment, I'm only interested in what is the interval that I'm referring to. Well, that is x is less than 3. So whenever x is less than 3, we're going to have this line. And notice the arrow on that means it goes all the way to infinity. So I can write it as strictly x is less than 3. Well, let's figure out what the slope of that is. Can we pick 2 points on there that are clear? Yeah, we got that point there and that point there. So let's figure out the rise over run from there to there. We got to go up 1, 2, 3, 4. And we got to go over 1, 2, 3, 4, 5, 6. So it's 4 over 6 is rise over run, but is it negative or positive?
Negative.
Correct. Means the first part of my equation is minus 2/3 x plus b. Now, we can't read b because it doesn't go all the way to the y-axis. So the question is what we could pretend and carry it all over the y-axis, but again, it leaves me at a spot that I can't really read correctly. So let's figure out what b would be. In other words, I've got this much of that equation. I got y equals minus 2/3 x plus b. How am I going to solve for b?
You could add the negative 2/3.
Well, I got to substitute a point that I know is on that line. What point is on that line?
Pick a line and plug in.
Yeah, and pick a point that is at a vertex of one of these little tiny grids here. In other words, that is,
No, it's
that looks like it might be, but that is for sure. We use that point to figure out the slope in the first place. So I would pick that point right there myself. What is that point? What is it on the x-axis?
I'm just looking.
Uh-huh.
It's -9.
Okay, what is it on the y-axis?
I said it's terrible. 6.
Okay, so that point right here is in our equation, which means it has to satisfy this equation. If I plug in 6 for y and minus 9 for x, it's going to be right. And notice what happens. That allows me to solve for b. Okay, so I'm going to plug in 6 for y, 9 minus 9 for x, and now let's solve for b. What is this equal to? What is minus 2/3 times minus 9?
Would be 18/3?
Correct. Positive 18/3, which reduces to?
Yeah.
What's 18 divided by 3?
reduce it.
Would have reduced to 6 over 1?
Or 6. Now solve for b.
So would be equal 0?
Correct. So what's my equation that represents that line?
negative 2/3 x plus 0.
Correct. So when I go up to here, it's just negative 2/3 x. That is the equation of that line. Now, what's our next interval? In other words, what's our second interval down here?
Negative 3x.
Not negative 3x. It's where x is actually, it's from here to the right. Remember, we're starting left to right. We're trying to always do these left to right. Well, this next interval is wherever x is greater than or equal to minus 3. Notice that covers the entire realm of real numbers. In other words, we have two intervals and two intervals only. We have wherever x is less than 3, negative 3, excuse me, and wherever x is greater than or equal to negative 3. So now we need the equation of this line. Well, this is going to be a little bit easier because it's usually not that hard to figure out slope. Let's figure out slope. What's the slope on that line?
It is 1.
Positive or negative?
Negative 1.
Negative 1. So that means the equation is negative x plus some b. And in this case, if we look at the graph, we can see that that thing crosses, it appears to be at a whole number. What is that whole number?
Negative 4.
Yeah, that means b is negative 4. I didn't have to solve for it here. I could read it directly off the graph. I could have extended this line all the way over and perhaps seen that it crossed at 0, but it wasn't totally clear to me that it did. Whereas this one, it's pretty clear that it crosses there. And does this equation fit this point? Well, when x is minus 3, yeah, y is minus 1. So this equation I've come up with, assuming that the b is at minus 4, which I did, fits every point we see on this curve. And there's your answer. Now, you understand the difference between open dot and closed dot?
Yeah.
Open dot goes with the less than or greater than. Closed dot goes with the greater than or equal or less than or equal. The arrow indicates it goes to all the way to infinity in both directions. So the domain would be all real numbers on this problem. All right, let's go to the next page. Okay, what we have here is a graph where the horizontal axis is time, the vertical axis is altitude. So when they say a skier is trekking up the mountain on a lift, this is what he's doing. In other words, as time goes by, his altitude is increasing. Well, that's where he gets off the lift, right there. Okay, do you ski at all?
No.
Well, when you get off a lift, you usually go on a flat slope until you get to the top of the mountain and you want to ski down it, which is what this is here. So that's what this graph is it's a graph of this skier's elevation with time. Identify the rate of change of each piece of the function and the domain for each. Well, we got how many pieces of this function? If this were a piecewise function, how many domains would I have?
3.
Correct. So let's talk about the first piece. When they say what is the rate of change, what do they mean?
How much it's changing over time.
Correct, but what else do we call that? That's what slope is. That's why they spend so much time teaching you about slope, is that slope is rate of change. And it's key in all of life. When you get to calculus, calculus is all about rate of change. That, in a word, that would be the definition of calculus, would be rate of change. And rate of change translates to slope when we're talking about a linear line, in other words, a straight line. Well, what is the slope of this thing? And how can we figure it out?
You figure it out by how much it's going up over.
Rise over run, right?
Yeah.
What's the rise? We need to pick 2 points, figure out the rise and the run. And let's pick some points that we're pretty clear we can read from the graph. In other words, that's 100 on the time axis, that's 200, that's 300. So, hold on, let me get rid of that thing. So give me another point on this graph that we would be able to figure out slope.
You could use 0 and 100.
Well, we could use 0, 0 as the starting point. So there's our starting point. Where's our next point? You're suggesting we take that point right there?
Yeah.
That's not bad. It looks like, let's see, that's 1,000. That must be 1,500. That's weird. That's going to be hard to read. It looks like it's halfway in between 1,000 and 1,500 on the y-axis, correct?
Yep.
If I was going to guess, I would guess 1,250. So we'll say that 100, 1,250 is also on the graph. So what's my slope?
It would be 100 over 1250.
Rise over run,
Sorry, it would be 1250 over 100.
which is the same as 125 over 10, which is a slope of 12.5. Now, let's see if there's any other points that are a little bit better defined. I'm not that comfortable with calling that point 1250 on the y-axis. It looks close, but the problem here is that no matter what other point I look for, I've got to make some guesses. In other words, if I don't pick that point there, I got to guess as to what the time coordinate is. In other words, let's say I wanted to pick that point right. Well, let's go for the 2000 point, okay? Well, now I got to guess as to where that is on the x-axis because they don't give me a real good grid here. So there's really no other point that I can pick that has any better accuracy than this one right here. If nothing else, I know for sure that the x-axis is 100 there. And yeah, I got to approximate what the y value is, but I'm going to have to do that one way or the other. So this isn't a bad rate of change for that first part of the function. And that's all they ask for. Now they did say, what's the domain for each? What do they mean by the domain for this part of the function? That's the part that belongs on the right. In other words, remember, we're looking at a piecemeal function here. We're looking at something that goes f of x equals, and there's 3 parts to it. Well, the first part was x greater than 0 and less than. Well, what is that point right there? Now, we do have to guess at that. I'm going to call that 180. In other words, that's 100, that's 200. 180 is as good as anything. That's the domain. this over here is the domain for that part of the function. In other words, when x is between 0, when the time is between 0 and 180 seconds, the skier is going up the mountain lift. That's about 3 minutes. That sounds about right from my days of skiing. Okay, what's the next part of the domain? If that's 180, and let's guess that that's 240, then what goes here as the second part of our piecewise function?
180 is less than 240.
Okay, not 180, but x, and greater than 180. Now, notice that I got two domains here that don't have an equal sign in it. Well, it's true if I say that right there. And the explanation as to why I want that to be continuous, I don't want an open circle there. In other words, his domain is continuous. Time doesn't stop existing right there. It keeps moving. The only thing is his elevation doesn't change. So I'm going to make this second domain x greater than or equal to 180, which is that point there, and less than, well, let's even make it less than or equal to 240, which is that point right there. Well, we already figured out what was the equation of that. The slope of that was 1250. So that was 12.5x. What's the y-intercept on the first part of that function? I'm sorry to back up here. I forgot to do the y-intercept, but we can see it. What is it?
0.
So plus 0 or just nothing. That's the function right there, 12.5 times x. When the domain is between 0 and 180, that's what his elevation is equal to. Okay? Now, when his time is between 180 seconds and 240 seconds, what is his elevation equal to?
You see that on there.
I'll tell you what, this really annoys me when they give you a graph like this.
Yeah, it's hard to read.
Well, this stuff is hard enough as it is without giving you a graph that's not marked well, and it's impossible to read where that is. But yet they expect us to do it. So let's put an approximate value of y on that. What do you think it is, Patrick?
About 2250.
All right, I'll take that as much as anything. That's the answer. In other words, whenever the time is between 180 and 240, his elevation is a constant, 2250. It doesn't change. That's because he's off the lift and he's skiing to the top of the mountain on a level area. Okay, there's one more piece of this function. What's its domain? What's this part over here? How am I going to define that with regards to the x-axis?
Let me see.
X is greater than what? And less than what?
I shouldn't read the goddamn board, so.
Well, I guess that was 240 on the x-axis, so that's what I'm going to put in there.
240.
To
Take a guess on that. Let's call that 350.
Can you see that?
Now, notice the one thing I did in drawing this up is I didn't leave any holes in the domain. And that's important. And the way I did it was I made this a greater than or equal, and I made that a less than or equal, and I made each of these just less than. And that way we still have a solid function. But I actually had some choices. I could have made that less than or equal, and then I would have made that just less than. In other words, you don't want to overlap. You don't want something like this. You don't want that. Notice the difference? In other words, I don't want it to be the domain from 0 to 180 inclusive, and then have this part of the domain 180 inclusive to 240. I want there always to be separation. No overlap here. If we have overlap, it's not a function. It wouldn't pass the vertical line test. So you always want to make sure that these do not overlap. And they also don't leave any holes. The way I've drawn it, it doesn't leave any holes. However, we still need the equation of this line right here. So, real quickly here, what is a good approximation of that slope? And here, I'll give you the values. The y value goes from, what did we decide? 2250?
Yeah.
Goes from 2250 to 0, his change in elevation. In what amount of time? Well, from 240 to 350. Okay, now notice that my sign on that isn't going to be correct. That is 2250 divided by 110. So it's 225 over 111, rather. What's the sign? What's the slope? What should it be? Positive or negative?
Negative.
Okay. There's an X that goes there. Now, this is another one that we have to solve for B, because obviously if I wanted to see where that line crossed this axis, the altitude axis, I would have to extend it on way past outside of our graph and then guess as to where it was. So this is another problem where we need to solve for B. But I've already taken you a few minutes past your time, and we'll have to leave it there. Because solving for B, once again, this is not the y-intercept, incidentally, right there. The y-intercept is where that would cross this axis if I continued it on. So to solve for B, I've got to pick a point, plug it into this equation, and solve for B. It's probably another 5 minutes of effort to solve for B. But when you're done, this is what you have. Well, I'll put in a plus B here, whatever that B is. Okay?
Okay.
All right. Well, that's probably as good a place as any to stop. Yeah. Any last questions at all, Patrick?
Nope.
And I'm sure, David, that we'll have to schedule another session this week, so we'll go ahead and pick it up. And I want to make sure, I have this feeling I'm short an invoice on you, but can you check
Yeah,
the record?
I haven't sent an invoice for the last. I'll send one at the end of today.
That's great. Like I said, I just don't want to get screwed up on you, because sometimes I miss them and they don't want you to
I keep pretty good books, and I just periodically send them out, sometimes after one session, sometimes after a couple.
Alrighty.
But I just haven't sent it yet, but I will after today.
Yeah,
Okay.
like I said, this stuff, I'm sure he's going to need more help with this, David. So
Yeah, this is pretty complicated. This stuff gives people problems, especially figuring out what the equation is based on the graph. And they didn't make it easy by giving us such a tough graph to read. I mean, there's really no excuse for that. They shouldn't do that. I mean,
all right, thanks, David.
All right. Talk to you guys later. Bye-bye.